Hello guys, welcome back. And myself Sheikh Fazan Nasir. Today I'll take you through the QuickSort algorithm. So as you guys have already been through your searching sorting live class and you already know what QuickSort is, still I'll just give you a brief about an example that I'm going to follow. So here I have this example of 70, 50, 40, 90, 30, 80, 10. All these examples we are having, right? And for these arrays we have to choose our pivot, right? So basically here what we have done is we've chosen the last element as our pivot, and based on this pivot we will separate our array. So the first half you can see is the greater end, so anything that is greater than 70 is put on the right hand side, anything that is less than 70 is put on the left hand side. We are basically creating a partition here using our last element, right? Again, we'll choose the last element, we'll do the partition. So anything greater than 50 on the right hand side, nothing is greater than 50 here. Anything less than 50, so all the things that are less than 50 are represented here. Similarly, here also you can see anything that is greater than 70, 80 and 90 are greater than 70, so 80 and 90 are here. Then the last element again in this sub array is what? 80. So based on 80 we'll do the partition, and 90 is greater than 80, so it will be on the right hand side. Nothing is less than 80, so nothing on the left hand side. So basically we have to find a partition first, and based on that partition we will continue this, and we'll continue this unless we get all the elements sorted out, right? So this can be done with the use of recursions. First of all we will find our partition, and then we'll look into how to implement the quicksort with the use of recursion, right? So first of all, let's go ahead and write a code for our partition. So I'll write def partition. This partition will take an array, the lower bound and the upper bound. So low and high will specify my lower and upper bound. Now remember, lower bound and upper bound are the indexes, while that we are going to use. So I'll take a variable I equals to low minus 1, and I'll take my pivot. So my pivot I've taken as what? My pivot I've taken as the last element. So I will say pivot is equals to array of high. So array of high will basically return the last element of that array. Now what we want to do is we want to loop through the array. So I'll write for j in range of low comma high. So from low to high, loop the indexes and check whether if array of j, which is any element in that array, is less than or equal to the pivot or not, right? So if it is less than or equal to the pivot, in that case what we want to do is we want to actually swap them. So what we will do for that, first of all we need to increment the value of I, since it is at low minus 1. So I will write I plus equals 1, and now I'll swap it with the I. So array of I comma array of j is equals to array of j comma array of I. Now once we have done this, we will get out the loop of, once we are out of this loop, once we have swapped these elements for the less values, what we want to do is we want to fetch the next index, right? So for the next index we want to do one more swapping. So I'll write for array of say suppose, since we have received our partition element I, so we'll start with I plus 1, right? So that will be our next partition. So I plus 1 from array of high. So I will replace that with my high, because my high is the pivot, right, at this point, equals to array of high. So I will just swap them with the pivot elements. So array of high comma array of I plus 1, and here finally we'll return the I plus 1. Now this is my partition, right? I have done the partition. Now next task is to actually do the sorting. So for the sorting I'll write one more function, def say suppose quicksort, and this quicksort function will also take in these parameters, since we want to find the partition every time we are doing recursion, right? So we need these parameters. And here first of all I'll write a condition that if the length of array is equals 1 at any point, then return the array itself. otherwise do what? Otherwise do the quick sort. So here I'll write if low is less than high, that means if the lower bound is less than the upper bound. Here for the upper bound we have used the variable high. So in that case only what we'll do, we will first of all find out the partition for every value. So pi equals to partition array for the low and high, right? So whatever low and high we have taken. Now next thing is what? Next thing is using the recursion to fetch the two divisions. So we have a left hand side division, we have a right hand side division, and for this array again it will do a left hand side division and the right hand side division. Again for this array it will do a left hand side division, right hand side division. Again for this array left hand side division, right hand side division. Actually partition it will do, sorry. So what I'll do here is I'll just write the recursive method here. So I'll just call the function again, QuickSort upon the array, and here the only thing that will change is the low and high. So first of all we'll pass on the low as it is, right, and I'll do pi minus 1. Now this pi minus 1 basically specifies that whatever partition you have taken, it's left hand side. So minus 1 basically specifies your left side, right? So the left hand side array we are doing here, and again for the right hand side we'll do here. So it will again iterate within itself using the recursion, and here instead of low we'll pass on pi plus 1 for the right hand side till the high element, right? So once this is done, our array should be sorted. So let's go ahead and utilize an array. So I'll write let's suppose lst equals to, and let's take these values only, 10 80 30, 10 80 30, 90 40 50 70, 90 40 50 and 70, and we're gonna call this quicksort function upon this array. So quicksort of lst, and the lower bound I have is 0 because indexing starts at 0 and ends at n minus 1. So len of lst minus 1, right? So now we'll actually look into the array and see whether it's sorted or not. So I'll print the lst, and the moment I run this you can see my array is sorted. So this was about the quicksort algorithm. I hope your query is resolved, and take care guys. I'll see you in the next video. Bye bye.